Okay, so on this one, guys, it's going to be talking about quadrilateral PQRT and quadrilateral KLMN or similar. So this is basically going to go idea a set of proportions, right? Where this one is kind of equal to that one, and the way it's set it up is going to be very important. So the idea goes back if 1/2 is equal to 2/4, you can have it like that, right? You can also write this one over 2/1 is equal to 4/2. But the way it goes, if they mess it up, and it's any out of the order, like maybe go 1/2 is equal to 4/2, then that's completely wrong. No way, it can't be mentioned like that. So we're going to come out here and erase this stuff, and let's make them coordinate, right? Very important, and what's going to be said here is this right here. PQRT is a triangle, or one of these equilaterals, or what are they called? Trapezoid. So we're going to set this one up, and make sure you know that it's usually this triangle is going to be, or this, I guess, quadrilateral is going to be, again, set up over here on this side, and this one will be set up on this other side over here. Very important to look what's going on here, right? So X, where's X? X is going to be between QP. I guess QP, right? So QP is right here. X, and that should be going over KL. Well, where's KL here? KL, 8.9. Is it over 8.9? So guess what? That doesn't go there. Let's try another one now, right? X over 8.91. So X, KP again, or QP, my bad, QP. And then it's going to be over 8.91. Where's 8.91? Oh, 8.91. Perfect. So that one checks out. KL, 8.91. And then this next one, okay, is going to be 4.12, 4.12. RT. RT should go to what? MN. MN over here is Y. So it should be over Y. So again, wrong. It's not going to work. Just matching up stuff. This is super easy, guys. Okay, so let me go back to the next one. Y, where's Y? No Y here, Y here. So now they went with what? Y, which is MN. That should go to RT. RT over here is 4 over 4.12. Wrong. Oh, look, it's already over here. Okay, so we're going to have MN going to RT. That checks out. And then we're going to have 9, which is KN. K to N should go to PT. And where's PT over here? PT should go to 3. And that checks out. Perfect. So my answer for this one is letter D. Hopefully that made sense. It's not too bad. It does take a little go back and forth, especially for the way y'all's tools are set up, but I'm sorry. That's the way it's going to go. Okay, so on this is going to be given to me, like instead of PQ, RT, and KLMN, it's going to be given to me these little arcs. Okay, so 1, 2, and 3, 1, 2, and 3. So the way it's set up is already. So this one corresponds to that one corresponds to that one, and this one corresponds to that, and that corresponds to that. So now we just got to make sure it matches up. So here we go. A to B. Where's A? A should go. A should go to here, 8. And here they say A goes to B. Oh no, I don't like that. Way out of there. Wrong. Here, 3.2 going to 2. 3.2 should be going to 2. Checks out. That's one that checks out for sure. And then A should be going to 8. And that checks out too. So find out G. Sweetness. Good. That's pretty easy. I can explain to these why these are wrong over here. B going to 6.4. Where's B? B should be going to 6.4. Perfect. We need another one of these arrows going this way. 8 should be going to A. 8 should be going to A, but here they said 5, which means they have it as 8 going to this over here. Not even the other figure. We're way wrong. I even say this is so wrong. It's wrong in so many different ways. And then 2 going to 3.2. 2 going to 3.2. That checks out. Let's just get another arrow from here going to that one. And B should be going to 6.4. But they have it now B going to A, which is wrong. They have to go to the corresponding sides. So that one's wrong. Definitely G is the correct answer. Oh, this is really easy, guys. These are dilation, rotation, reflection. Keyword dilated. Anyway, I was just going this way to go to read it, and it says dilation. That means to multiply. And here, it says, right here, here's the rule. When I'm writing that, I saw the rule here. So that means to multiply by 3.5 or 3.75. So each angle, no, nothing about the angles. No, nothing about the angles. The side lengths, okay, because it's going to get bigger or smaller. This situation is going to get bigger because it is bigger than 1. Length would be 3 times, yeah, that's it, 3 times. Boom, 3.75 times actually. That's your answer. This one says more, like to add. No, this one it says 3.75 plus. We're not going to plus, we're going to multiply times, remember, times. Okay, so this next one over here. Again, dilated keyword. I haven't even read any of the words, okay? It's dilated, it means to multiply. It's also not congruent. Again, not congruent. Just come out here, side length there, 1/2. Oh, what are they multiplying by? We can't figure that. They didn't say here. It's not congruent. For sure not. Oh, great. Let me see the answers. So for dilation again, the word was dilated. It's going to be not congruent. And please make sure you know the other word that goes with that is going to be similar. It is going to be similar. Because each side length of the quadrilateral PQRA is 1/2 of the corresponding of PQ. So it's saying the bigger one, PQRS, you see that, is 1/2 of the smaller one. That's not even close. It gets bigger, definitely gets bigger. We can figure out that later on if we need to figure out what size or how much it gets bigger, but let's just go through here real quick. Remember we said not congruent, so that one's out. We don't have to worry about the numbers yet. Each angle measure, no, we're talking about the angle measure, we're only talking about the side lengths, and then here's the word similar, checks out. So that one's really easy. This is a STAR test question. This is a STAR test question. Okay, so let's see this one real quick. This one's triangle PQR is dilated, so if it's dilated, that means to multiply. PQR is dilated. And then it's going to be going out to become PQR, so that means it's got multiplied. So now, I like to keep it real simple. Now, for me, I'm going to look at P, and the PX value, my bad, the RX value, and the R prime X value. And this is based off of a multiplication, okay? So what did I get? 1 times some magical number equals 3. Well, it's going to be 1 times 3, guys. So it's by 3x and 3y. Answer would be 3x, 3x, and then 3y. Now, sir, I don't get that exactly. Well, then basically get the x and y's, right? Or get the same side length, whatever you want. I'm going to compare the x values of the r and r prime. And remember, scale factor is going to be known as the new over the old. The new one is a 3 over the old one, which is a 1, which now gives me 3. So they multiply by 3. And there it is, 3x, 3y. Same idea over here. My gosh. I need to zoom in. The copy is so bad. Hopefully your copies on paper are so much better. Let me just see what I got here. I'm going to say this is 12 and 8. 9. Okay, so on this one, the rectangle is graphed on a coordinate plane. The table, yada, yada, vertices. I can't even read this. Dilation, it means to multiply. Okay, multiply. Now what happens is you want to go ahead and get the scale factor for this one. You need to find out the scale factor. Oh, it's to multiply. So it can't be this one, it can't be this one. Now actually, looking at the answer choices, this one here is what's 3 over 2, which is bigger than 1. And this one here is 2 over 3, which gets smaller. So just look at the numbers actually. And you have to compare. This is your x, this is the original, and this is your y. This is now x prime and y prime. This is the new one. This is going to be the old one. This is the new one. So let's compare it easily. Look at this. Easy. This 12 is going down to an 8. This 9 is going down to a 6. So it's decreasing. It's getting smaller. My answer is B. Now, sir, just double check. How do I get 2 over 3 or 3 over 2? Get the new one. New whatever you want. So since I started off with the blue ones, I'll go with the blue ones. And I'm going to show you. The new one is, well, the old one is 12. The new one is 8. And it's always going to be new over old. The old one is 12. The new is 8. Now, put that in the calculator, and it's going to simplify down. You divide them both by 4, basically. Gives you 2 over 3. Which now is this answer right here. Oh, this is easy. Scale factor. Hey, guys, I'm just moving it over right now as we speak. This says dilated, scale factor, multiply, multiply, multiply. Multiply at 3/2. That's like, dude, that's like a dead giveaway. Let me see, does it say dilation here anywhere? Well, up here it said dilated, okay? So dilation, and it says by 3/2. That's easy. So the rule would be 3/2 x and 3/2 y. Boom, that's it. This is add, this is 2/3, not even close. None of these make sense at all. This is a translation to move it over to the right and up. This is the right and up, but no, not even close. Dilation, multiply by the number they told you. Now this one you have to figure out exactly what it is. This is another STAR test question from a couple of years ago. Again, polygon, whatever, LMNPQR, yada, 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 shape, yada, yada, yada. Dilated, multiplied. It's multiplied, okay? And now they came out here. The new dilated, the origin, yada, yada, the vertex Q prime will be located at 21,7. The vertex Q prime will be at 21,7. I'm going to go with Q prime. 21,7. Okay, so this is the thing right here. This is really easy. That's Q prime. Q prime would be way off the charts, getting over here and then going up. That's Q prime. Look how far it is from the origin. It's just getting further, way high up there. What am I going to tell you is that this is definitely going to get bigger. It's multiplication, so these are out. This is 2 over 7. That gets smaller. This one here is 7 over 2. Definitely getting bigger. That's my answer. But now let's just double check how do we get those answers for sure. So remember, it's new over the old. So Q, the original Q, is 6 over 2. I'm sorry, 6, 2. Hold on, guys. So this one, don't forget, it's always going to be the new over the old, all right? I always go the new over the old. Now, new what? You compare. You want to do x prime over x, or if you want to do y prime over y. Pick it. So we'll go 21 over 6, and that's the x's, right? And if I divide them both by 3, I'd get 7 over 2, and it checks out. If I would just use the y's, look at this, the y's alone. Look at this, 7 over 2, easy dead giveaway. Okay, so this one here, let me see, it's going to be translated again. I mean, dilated again. Let me see. Oh, it's a rule. That one is a translation. You see how it's x plus 9 and y plus 4? It just slides it over to the right. This one slides it over, guys, to the right and then up. And let me see, what rule does it say? Well, that was a translation, okay? Now, if you see that as a translation, there's some words I told you need to be remembered when you say the word translation. The words are going to be, ready? Congruent for sure. Equal. And the same. So we're going to come down here. We're not even going to read the whole thing, just for those keywords. Twice, obviously out. Equal, check. Longer, which means more. No. Greater than more. Final answer B. Okay, this one over here. Oh, preserves congruence, does not preserve congruence. I'm sorry, I didn't even get to read this up here because this is how easy this is. Once you see that, oh, that's easy. Anything that preserves congruence, okay, is going to be everything but dilation. Everything that is not congruent is going to be dilation. So these, just for dilation, reflex congruence, rotation congruence, dilation not congruence. That's it. And that's what we're telling you this because you do need to know this rule. This one is a dilation not congruent. That's it. Just quick, easy memorization stuff. Okay, so which representation of a transformation on a coordinate grid does not preserve congruence? Not congruent, guys. Not congruent. That means dilation. Dilation, and that's dilation. You're multiplying there. This is a transformation. A translation slides it to the right. This is a reflection over the x-axis. This is a rotation 90 degrees clockwise or 270 counterclockwise. Okay, well, this one says translated to be slid. So that one's going to the right. So on the x-axis, you're just going to the right. That's going to be x plus, okay, positive 3. So it's going to be x plus 3. And it says nothing about going up or down, so it's just x plus 3y. Ooh, counterclockwise. I saw this last year, guys. First time it ever came out on test, counterclockwise, right? So we're going to remember the rules, and counterclockwise is the same thing as clockwise, just, opposite direction, but same way to set it up. So we're going to go 0, 90, my bad, 180, 270, 360, xy, yx, xy, yx, xy. When that happens, the first and the last, not the, nothing changes. The middle one's 180, but that one's like a dead giveaway, right? Easy how it is. But let me go back here. Negative, to the clockwise would be to the right. Counterclockwise would be to the left. And if I go to the left, that's going to go first to the left, and then to both, and then to the right. So we're looking for this one here. So it'd be y, negative x, y, negative x, y, negative x, and there it is, delta d. Easy, guys. Counterclockwise, that means to the left. You go first to the left. Remember, the first and last don't change, so first move would be to the left. So I go to the first left thing right here, and I just slowly creep away to the right. Okay, over here. A rectangle, I'm sorry, M and PQ is translated 4 to the left. Ooh, that one's easy. So it's going to be x minus 4, and 3 up, and y plus 3. In case you forget that, that is just based off of the x. This is to this other one, right? So this is like this. If I go to the right, it's going to be x plus. If I go up, it's y plus. So just looking at that, we're going to have that. Oh, it's going to the left. So that one's going to the left, my bad. Would be x minus. This is the x-axis minus. So x minus 4. Ooh, I can't tell. I think it's this one. X minus 4. And then we'd have y plus 3. I'm going to say it's down, y plus 3. This row here, too. Translate left and to the right. So 4 units to the left. This on the x-axis, this is going to be x plus. This is x minus. Going up and down, this will be y plus. This will be y minus. So it's going to the left, so it's going to be x minus 4. And 5 units up, and then y plus 5. So x minus 4, check. And y plus 5, check. Final answer A. Okay, the coordinates are here. Okay, this transformation does not produce a square with vertices at the same set of coordinates. This is when I first read it, kind of threw me off a little bit. It's basically saying I could do this figure, right? Let me draw a figure. I'm going to draw it here. I'm going to connect it in one figure. And it's saying if I were to get this square, and just say I rotate it, you see how they all wind up again, even though I'm not in the same starting spot? It's saying doing that, rotations, okay, how they landed up in the same spot. It's saying which one would wind up where the vertices don't wind up on another vertice? What? Like if I were to turn it. and it winds up like that. When would it wind up that the vertices on the red, you know, go back, and I did something to it, would not wind up on the vertices. So what it's saying here, I need to move them off of this thing. What if I were to just get this whole thing and slide it? What if I were to just get this whole thing and slide it right or left, up or down? Well, isn't that a translation? Wouldn't that take it off the other coordinates? So which is a translation? B. That's the only translation. This is a reflection of the y-axis. This is a rotation of 180. This is a rotation of I guess, counterclockwise 90 or 270 clockwise. So it's up to you how you look at it. Oh, this is really easy. Look at this transformation. ABC was moved to get to ABC. What did they do to it? They translated it, right? They moved it. If you look at this, I'm going to go with C too because I left it where C you can see in C prime. C moved what? Did it go right or left? No, it just came straight down. So on the x-axis and y-axis, if you go straight down, that's going to be y minus. Now, how many units did it go down? From here, it went down 1, 2, 3, 4, 5, 6, 7. So y minus 7. There's my answer. Pretty easy because I just went down. I didn't go up or down. I mean, I didn't go right or left. I just went up. From up here to down here. That's just a negative movement on the y-axis. Pretty easy, guys. Let me see this one over here. So we have pentagon, yada, 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 yada. Reflected. Okay, reflected on the x. Remember, there's a rule here for reflected. Okay, so reflected, hopefully I remember, reflected, FL, means fixed. My bad, fixed life. And they said over the x-axis right here. So it's going over the x-axis. The original thing is x and y. It switches only, well, what happens if it stays fixed? Let me go back to the main thing. It stays fixed as the x stays fixed. It stays first, and it stays exactly like itself. This next one over here was now it's opposite. So look for this row here. X, negative y. Ooh, A again. And that's it, guys. These things are pretty simple, pretty easy. Took me about 20 minutes. I think you can do it pretty easy, too. So have fun. We'll see you tomorrow.